Thank you for coming to this session. I'm Simon Burbridge. I work for DRI, same place as Alistair, the previous session chair. I've been around in HPC for a long time. I've always been interested in the new stuff and the kind of newfangled bits and pieces and exploring new architectures and things. So I'm hoping this session will be something that explores some of this stuff in depth. We've got a panel of people, some of whom are terribly interested in technology, so I'm sure they'll be able to share lots of interesting stuff with you. So reintroducing people, start with Chris at the far end.
Yeah, so I've been thrown into this one, but I promise I'm meant to be in the next one. I'm not doing the next one, just because there's too much me, and I don't want to do too much. You'll be totally bored of everything I have to say. But I'll add as a new bit of introduction, as I was a computational chemist, and what I did as my research career was to try to solve the protein ligand binding problem, like two things actually bind together with complex simulation. And my colleagues were trying to solve the protein folding problem using hard, physical models. And we always viewed these two problems as being pretty much unsolvable in a 10 or 15 year time frame. And then it was 7 years ago now, when AlphaFold appeared, and suddenly went from not being able to solve the protein folding problem to you can predict the structure of most globular proteins. And now with AlphaFold advances, you can predict the structure of most proteins, and indeed protein-protein binding, which is amazing. And this was almost a switch overnight, where we went from not being able to solve it to machine learning solved it. And now it was like crystallographers across the world were like, rats, we don't need to crystallize it anymore. That was annoying. People who are trying to solve the protein folding problem using physical methods, rats, it's been solved by AI, ML. And it was almost went unnoticed, I would say, within the general world community. It wasn't the big bang that a GPT was, but in the computational chemistry community, it was like, bang, AI has arrived. And that feeling of it coming was really impactful in my career. And I think that's why I've had this interest in how AI applications are going to directly impact the way all of our researchers work.
Well, if AI's been around for so long, it's not novel then, so we should be talking about it here.
Yeah. It's novel that it works. It never used to work, and that's always the way that it's like, not work, not work, not work, not work. Suddenly it works, and it's a step change. And that's the thing which is really weird. It's not like a physical model where you kind of gradually approach it working. It really doesn't work until it suddenly works, and then the world is different.
So, Alistair, Basden, Durham University, and I guess I'll go into a bit of my background, like Chris is. So, my background, I'm an instrument scientist mostly for astronomy, cosmology, that sort of thing, and so I've been involved making some of the instruments for some of the world's largest telescopes, the James Webb Space Telescope as well. And in terms of machine learning, we were using that on telescopes for atmospheric correction about 10 years ago, something like that. So again, not novel there. And I guess you could say I'm a failed postdoc, because I basically never managed to get onto that academic career ladder. So,
never mind. Commiserations. Phil.
If that's what failure looks like, that's okay. Maybe we've been chasing the wrong thing. So I'm still Phil Hasnip. I'm still based at the University of York. I'm still doing research software engineering. The clock is ticking. My first computer was a ZX81. Yeah, so the only computer I ever had where I worried about whether it would crash if I pressed a key too hard. Yes, it would. I guess in terms of novel technology, so things have gone around a number of cycles, and what we consider novel sometimes isn't novel. It's just we haven't seen it for a decade or so, but if you go back far enough, that's how things were done. So my interests have always been in ways to do things better generically in terms of hardware, but also in terms of software. And my personal interest is in taking what would be considered difficult algorithms, difficult problems to solve, and creating something that allows ordinary researchers to use that. So in a way, doing away with the need to have a computational specialist in a large experimental or a research team, and be able to present software in a way that anyone who knows that field can ask it questions they care about. And I know that sounds a little bit like AI, but just normal, as a normal software goal, that's my interest.
Yeah, hi again everyone, so I'm still Bill. I'm afraid you're going to see too much of me today. So University of Manchester Library, my first computer, because I haven't done this yet, was an Amiga 1200. Yeah, with a 64 meg hard disk in it. Favourite, well, I'm not to say favourite novel technology, but maybe a novel technology that is relevant within the broad sphere of DRI. So I'm almost certain that other universities in the room have got these too. We got a safe pod at Manchester a couple of years ago, thanks to the Research Lifecycle Programme. For people who don't know what a safe pod is, it's kind of like, it looks a bit like one of those fancy home offices that you get in the garden, the kind of a beautiful wood panel kind of shed. But it provides access to secure databases and data that things like the UK Data Service and the ONS provide. And previously, if researchers wanted to access these databases, they would have to travel to the data centre, so they'd have to go to London or wherever. And obviously, across the UK, that is train time or car time or whatever. And we've found that having the safe pod in the library, and it's based in the library, it's getting more and more popular, and it has almost democratised access to some of these databases because people don't have to plan journeys to do this. They can literally come and work on campus and do that. And the other thing that is nice, I think, for us in the library is that we see that the library is hugely used by undergrad students and by master's students and by PhD students. But once people become researchers, they barely darken the door of the library again. And it's just one of those things that we have which we hope helps to remind researchers that the library is there for them too, not as a physical space and not just something online. So yeah, the safe pod.
Thank you. Well, my first computer was one I built myself with a Z80 processor, and I had to solder on thousands of chips onto a motherboard, and I paid for an upgrade to the memory, which meant I had another card which had, I don't know, a lot of DIMMs to solder on that had 48k of RAM. Luxury. Oh, and not forgetting software, it had a BASIC interpreter. That was novel at the time. Oh no, it wasn't. Okay, so the very lovely people who've been running around with microphones have told me they need to get their steps up today. So in this session, if the audience have questions halfway through, raise your hand up or from the internet and we'll make it a very interactive kind of thing. If it's really boring, just stay asleep. So the first question I have here is for the panel. You have something that works. What was the inspiration to seek out something else? So novel technology, that's something that's disruptive for what you're doing. Alistair, you look excited.
I think for me, coming from an instrument background, the way I design these large computers is I do it a bit like a telescope instrument. So there's always bits you can add on, bits to make it more interesting, bits to make it work better. So some of it comes from that desire to kind of explore a bit more and improve it.
So that's kind of evolution rather than revolution.
A bit of both. It can be a bit of both. You know, if it's already a system in place, it's evolving it to make it more appropriate. If there's suddenly money for a new system, again, it's doing the same thing to try and design that. The benefit of doing it in HPC, of course, is you don't have 10, 15-year design cycles. You just, you get the money and you spend it, and it's great. You know, so it's like building a telescope, but without the documentation.
Is that a lesson we want people to take away?
It's much more exciting. It's much more exciting.
Well, it is fast moving, definitely.
That's right. That's right.
Something we can't forget about HPC. And
I'm sure Alistair will be running a Dockathon in another year or so.
But take JWST for example. It was first scheduled to go on to be launched in 2009. I think we've probably still got a poster in the department somewhere that says due for launch in 2009. And it went up. It was Christmas 2022 or something, wasn't it? Anyway, that just shows you how much time. If we did that with HPC, we'd never get anywhere, would we?
Could I maybe throw something in?
Yeah, of course.
Yeah, so this is, I'm afraid I'm going to be very library side and very open research side because that's kind of why I'm here today. But this is actually kind of prompted by a conversation I had with Kay from the EPSRC, who's here today. So in terms of open research data, the EPSRC were, I think, the first people to make it kind of mandatory that data be published alongside the outputs. And that really spurred on lots of universities to get their own research data repositories. So at Manchester, as I said before, we have Figshare. I think it really drove the move from people, there was obviously a very active data publishing community in disciplines where that was already serving the needs of the community to share data. But the wider world of open research data that, and we're not doing this purely because it's for compliance and because it's mandatory, because we do it because it is a common good. But I think that kind of inspiration from the funders to build this into our infrastructure and into our environment is something that has been a really positive thing. So we have Figshare as a general research data repository for the university, and we're getting good engagement with that, and particularly for researchers who don't have a repository of choice that attaches to their particular work, then Figshare is a great choice for that. And I think that's something where if we're talking about something that works, well, the old system of people doing it to disciplinary repositories was working pretty well, still does. We help people to do that where they need to, but having a wider net to do that from, prompted by input from funders to help kind of make this something that will happen, has been really positive too.
So do you think researchers actually want, because researchers don't like having to do stuff,
Yeah.
do you think that researchers now actually think it's a good thing and they embrace it, or is it still a problem?
Well, yeah, I mean, I won't labour on this too much. Yes, I mean, there are some researchers who, they've got no interest in doing it whatsoever. However, I think, within the library we are advocates for this, and we do lots of training and we do lots of engagement work to encourage people to think about open research and open science, and particularly open data as something that is not just something you do at the end of a project because you have to, but to do this because there are many other reasons why it's a good thing. And I mean, hopefully, I see a colleague in the room who is a huge Figshare advocate at the university. We get the word out there to people who can show how these things can help their research have a greater impact and greater reach, and reach a wider audience of their peers and the people they want it to get to. And that then it doesn't become self-sustaining entirely, some of it. It does help make the case for us, yeah.
Could I add, I think when you say you have something that works, I think that's the statement that sometimes bears looking at again. Sometimes things don't really work, right? I mean, I'm sure many of us will have had some legacy software to maintain and look at again. Sometimes the idiot who wrote it was you. And you look at it and go, I mean, it did a job at the time, but maybe that's not really working. You change compiler and it breaks, and there's only so many times you can say it's the compiler's fault before you take a look and realise, it doesn't actually have to do that. I just assumed it would do that. And there's also a bit of ambition that maybe there's a sort of minimal product that you might have produced that a PhD student could wrestle with over 3 years and end up with or 4 years or 5 years, and end up with a dissertation that gets them a PhD. But is that really a bit of software that is solving that problem? And is it something that you could give to another person and another, maybe even outside your field, and could it be built upon? Could you wrap it up, your C or your Fortran, and could it be called from Python? Could it be part of a bigger workflow? I think just saying this works, it's worth looking at that again. What do you mean? What's your ambition?
So you're really nicely following on to the next question, which is how do you persuade people that you need to move on to another? I'll come back to you, Chris. But there's a segue into that. You've got this program which actually doesn't work. So what do you do with your community to say, I've got a brand new one? How do you convince them?
I mean, I would say that people get quite enthusiastic actually if you give them a goal, if you give them a vision and say, right, this does this, but it really nearly, if we just did these little bits and rethought about it, look at what it could do.
Right.
So, look at, so in my background, my scientific background is materials modelling, not completely dissimilar for Chris's background. And one thing that's been a huge thing in the last maybe 10 years is not understanding just why this material has this structure, but in predicting new materials and their new structure, and going to the point of, okay, and then the new properties. And then so could we turn it around? Could we say, I need a material that absorbs light at this certain wavelength because I want to build a solar cell? Is there a way of doing it? And increasingly we're having tools that you can go at it with a property and say, right, what materials exist with these properties? If that is done with the direct simulations, that is how the field I grew up in, that means that a simulation, you should be able to ask it crazy questions. You should be able to give it a structure where atoms are sitting, it makes no chemical sense for them to be there. But you're going to try everything. So you're going to try things that are sensible, but we've tried those. The interesting ones are the not sensible ones, and the software has to cope. Even if the answer is no, the software has to kind of say, no, that doesn't exist, not crash or run out of memory or whatever other things. So it's about presenting something in a way that is accessible and reliable, even if it's a crazy question you're asking and the answer is crazy, but it should give you the crazy answer.
That's a really great example of how computational science can drive real science, which is the reason we're all here. So thank you for that. Chris?
So I'll answer both questions. So I am a researcher, come from a research background, and as soon as something's working, it's not research anymore. You're always trying to do the new thing and build the new thing. Once something is working, it becomes commodity. And actually the change of something that's working is it becomes value engineering to make it do that same thing more efficiently. And I don't find that personally very interesting. How I'm running a service, I don't know. But then in terms of how you motivate change, the pace of innovation is huge. And if you were stuck doing the same thing for 5 years, you have been outcompeted by your peers. The classic example, the one that motivated when I presented to Treasury and to ESET officials on AI, was you have in Silico Pharma, who built a completely AI drug discovery platform that basically produced a lead compound that went to clinical trials and is doing relatively well. And they did that in, I think it was 1/5 of the time and 1/10 of the cost of a traditional drug company. And this is what happens. You get these technological changes which then completely disrupt entire industries. And the reason people all talk about ML is because ML AI is going to disrupt most industries. If you were saying to a researcher, your thing works, and they want to say, I want to keep happily doing my thing in my space for 5 years, then you say you are making yourself at risk of being disrupted. You are literally preventing your career from developing because you're not looking forward to where you need to be sitting in 5 years' time, 10 years' time. And as much as I know we all hate change sometimes, and we hate the idea that we continually have to keep getting faster and bigger and better and doing more and more, that is just the nature of the innovation-driven, capitalist, competitive economies that we work in.
I think one thing that's quite important actually is we if we decide to, we can live in a quite high risk environment where we're taking these changes, and it's important to be in an encouraging environment. So I mean, I'm probably, hopefully most of us here can say this, but I feel I'm quite lucky that I'm encouraged to take risks, and that if something goes wrong, I don't have to try and hide it from senior management or anything like that. We can be open and honest about mistakes and that sort of thing. I think that's encouraging, and that's important, because that then encourages you to be able to take risks, to develop new things, to look at new ideas. Whereas if you were always trying to cover yourself, you wouldn't be taking these and you wouldn't be developing. So if you're there in a position where you can come down on people like a ton of bricks, then don't encourage them.
100% agree with that.
So, yes. Oh, sorry. Yes.
Hiya.
Questions.
Sorry. Hi, I'm Zay. My first computer was a laptop an average laptop you would have got in 2005. I used it for 10 years. It even ran Sims 3 at some point, but I put a bag of peas on top of it for it to cool down. But yeah, rather than looking at technologies we had and moving away from them, I kind of want to ask you a question about going full circle and going back to them if they develop enough over time. So there has been a paper from the university in Shanghai in China recently about CDs and DVDs, optical drives, and they found a way of storing petabytes of data on those optical devices, and the whole idea behind that was to, for one, reduce how much area your data centers would take, reduce the cost of archival storage and whatnot. And do you think this novel CDs and DVDs are going to have a comeback and have an impact in our lives soon?
So I saw the thing that you're talking about there. It was multi-layered things, sort of different wavelengths and so on, which as an optical physicist was interesting. Yes, I think certainly if that sort of thing became available to buy, it would be very interesting. You know, you would have to, as always, you would have to look at what at that particular time, you know, it's probably multiple years away from TRL 10 or whatever, but you would have to look at the time, what else was around, and so on. And of course, storage capacity itself might not be the only thing you have to look at. It might be read and write capacity, because if it takes you 3 years to fill up one of these disks or something, because. Yeah.
But I also think it's a good example of everything is old is new again. And if you're a researcher and someone is telling you, oh, CDs are dead, DVDs are dead, don't like waste your career researching them, and you really think actually I can make a difference, and if we can solve this one problem it would be a disruptive change in the landscape, then you know you can get funding for it and articulate that, then go for that route. It's kind of like having the vision to see how a technology could be repurposed. And I think pretty much every technology that we're using, you can trace it back to like a primitive version, like 50, 100 years ago. There's like nothing really truly new has been invented. We're just using them at a higher scale. And so it's having the vision of what could be possible, and then kind of like then the determination to drive it through. And one of the things I do admire about the Chinese strategy at the moment is because they're throwing money at everything. All of these weird things that we would be very difficult to get funded, let's make CDs, take petabytes of data, they're just doing, and you're getting all of this innovation happening in weird random ways.
Could I maybe lean in with I'm going to labour an analogy here, which may or may not work, so forgive me. So I'm a quite a tedious film fan and love films and still buy lots of CDs and not DVDs but Blu-ray discs and all that kind of thing, because loads of films are not available on the streaming services and never will be, and lots of them get removed from the streaming services. And there's an analogy there for me with the data that's been generated at universities in terms of how you access and preserve that. I'm leaning into preservation really. This is the thing that the library is, obviously, you know, preservation is one of the things that we do, and I'm being honest, at Manchester at the moment we don't have a joined up strategy for research data preservation, and we're looking at it in the new volume of our programme. And it would be really interesting if it came to it that something pops out which is a physical medium for that, rather than, there's always the next big thing in terms of technology around cloud and those types of storages, but maybe we will return to something that is a physical medium for that. I don't know, but yeah.
So that would be, if you've got a petabyte per DVD, that's 10 times the capacity of the largest LTO tapes now. So it's a 10 times factor in the amount of data you've got to curate in the library. How are you going to deal with that?
Come back in 5 years.
Or maybe we're looking for some software to help.
Well, we probably, without facetious answer, we will look at AI to help with that. When we talk about patterns and collections and the way it can help us do that real legwork without humans having to eyeball it, then yeah.
Any other comments from the panel? So the opposite of that, what grounds your exploratory activity? How do you ensure it doesn't become a vanity project, self-indulgent, and not something brilliant, good idea, something that will work?
When I set up the RSE group, and particularly when we went for the RSE thing, it was about sacrificing your own agency a little bit. So it's recognising you're doing something you're enabling another researcher to have the agency to explore something. So if it was a project where I was doing it because I wanted to do it and I wanted the output, then that was me serving myself. And that wasn't actually what I was employed to do. I was employed to enable other people and to lift them up. Increasingly, as I move more and more into service roles, you tend to use the word customer, and I apologise for people who don't like the word customer, but ultimately someone's paying for my time. And the way I ground myself is basically, am I delivering the value for what they're paying me to do? And if I'm spending my time building something that's for my own interest, that's totally fine for me to do in my own time. That's me paying myself to do that. But it's always got to be serving that need from the person who's paying you.
And with RSEs, it almost is a customer and supplier relationship, because often you're being paid from a grant directly.
So I think for me, I've got a dislike of shelfware. So if I get a piece of kit that's, you know, novel or whatever, I don't want to just have it sitting on a shelf. I don't want to just try it and put it back. I want to put it out there so that people can use it and make use of it and allow users onto it. and it's fairly easy for me to do that because we've got all the national infrastructure, so it's easy for people to get accounts and then access bits of hardware.
I mean, I think there is some room for a vanity project, and I think I'd encourage. Most of our universities have signed up, for example, to the Researcher Concordat, which allows typically 15% of a researcher's time to be spent on something that they themselves are interested in, really for a professional development point of view, but it can be something that you just think, I really want to do this, why not? We're in an academic environment, so why not use that? Where it becomes a problem is when that's all you do, and that, you know, controls your week. So 15% is a lot, but it's not the other 85%. So I think it's just about having, in that sense, it's about having realistic boundaries and realising your time and your energy is finite. But if we focus too much on the outcomes, then we miss some of the things that Chris and Alistair were talking about being able to fail, you know, and that actually being useful. You know, you might have a great idea for doing something. Oh no, it's not a great idea. Oh, it was a terrible idea. Now I know why no one did that before. But unless you've tried it and tested it, you will miss the new breakthrough. If we stick to what's just safe and what we know will deliver and what we can sign on the dotted line and say, yes, UKRI, I will do this in 3 years, please give me the money. If that's all we do, it's not that much research. If it's so foreseeable that it's absolutely going to deliver, it's almost like a service level agreement.
So it's development rather than research.
Yeah, I think if we're going to have some research in there, we have to do something a little bit more involved. And it's not a vanity project, but of course you play to your strengths and you go with your interests. So I would say it's a balancing act, I guess, is what I'm saying.
Yeah, and I that's a kind of important thing, I think, at the moment in the research infrastructure and funding of research, that there's a lot of pressure to deliver results, which mean, you know, either a paper or something you can do with industry or something that makes the university some kind of money in some way. But if you only do that, you aren't having original thoughts, you aren't doing any blue sky stuff, so you're potentially missing a lot out. Like what might happen if you revived old technology like DVDs, you know, in the light of the chemistry and physics and manufacturing you've got now that you didn't have 30 years ago.
Could I add as well? So in terms of research software, so I run a research software team in physics, and we are mostly trying to do research with the software we develop, as well as producing the same software for the community. But even in central RSC teams, which does have perhaps more of a almost a client model, or I would encourage everyone, give those people scope to say what they think the software should do. You know, if you get a software professional involved in an academic research project, they might have a much better idea of what software could do. They might know what works might look like for software more than you. You might know what your domain needs. You might not see what other people could use. And even at the level of I mean, I am an RSC, so I focus on that. But if you've got a system administrator, you know, don't just let them look after your system. Let them have some input into what your next system looks like, or how they think it should be considered. You know, it's not necessarily just going to be Windows or Ubuntu or whatever because that's what you always run. Maybe there are better things, or maybe there are things that will be supported more, or you know, give people a bit more input and agency in what they do.
Absolutely, I think that's a really important thing, and quite often our supercomputers now, particularly the ones right at the top, are sort of designed by committee, and that process can lose the link with the research base. So you end up with a machine that's pretty good, but perhaps isn't as good as it could have been. So having that kind of collaborative co-design with your sysadmins, HPC providers. Oh, I don't like that word, providers. Yeah. The HPC technologies can be a fruitful thing to do as a collaboration, definitely. Let me see. On a kind of more personal level, who have you managed to take with you on the journey, and what has been the value, the impact of doing something with somebody, with a partner, with a colleague, rather than going on your own.
Get a lot more done at a very simple level. I mean, personally, I think I enjoy working as part of a team. I like having my beat to focus on and maybe hyper-focus on occasionally. Let the world pass you by. But everybody brings their own skills and their own experience and their own ideas of what is and what could be with whatever you're working on. And sometimes someone will come up with an idea and the answer is, I don't think we can, it's not practical, we can't do that. But wherever possible, I think it's great to explore those and to see what your idea for what might happen might differ from someone else's. And often that's very constructive. And even if it isn't, I think you end up with a better, I'll say, product, whatever that might be, software or hardware. It ends up better in the end for having had those debates, discussions that come from having different viewpoints, people with different ideas around, well, let's say security, for example. Oh, I'm just writing plain text output, I don't need security, And maybe that's true, but at some point someone's going to have to care about security. So maybe there are things you could do that would make the next person's job easier. If you don't have anyone in the team who's interested or skilled in that, you're just delaying those discussions, or maybe even making sure that your software is not the one the community will ultimately end up using. So in terms of how you work, working with other people has challenges, but ultimately it's great.
I was head of RSC and I was part of the movement to try and create RSC. And the thing I'm most happy about with this movement, the thing which I feel was a success, is I was a postdoc, kind of like an RSC, on short-term project for about 10 years. And in that, you can't really buy a house, it's difficult to have a family, and blah, 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 blah. And the thing which I got most happiness from was actually being able to have that environment where members of the team had that job security, so that then they're able to, when they're buying houses and having children and everything, I felt so happy about that. And you get such a feeling of, like, you're helping these people grow, you're helping them develop. And that's when you realize that technical management is a really fulfilling thing. So somebody told me that the job of a technical manager is to build the environment in which you would like to work, but you'll never work in it. It's like it's a Moses position. You get to lead them to the promised land, but you're not allowed in. And what you do in that sort of role is you suddenly realize that technical management and working with people is where you go from being someone who's sort of additive to a project, where I can work a bit harder and I can sort of add a little bit of my own thing, but you then move to being someone who's multiplicative on a project. You can grow a team of people and make them all 20% faster, and suddenly you've got an extra person. Make them all 50% faster, you've got 5 more people. And it works in reverse. A bad manager can make them half as fast and you've lost 5 people. And it's that ability, the feeling of actually being able to work with a team and energize them and motivate them and get them to explore their ideas. And when I did say we have customers, again, you protect them a little bit from that demand, so that then they have the freedom and they can begin exploring things and you can develop stuff with them. That's a very rewarding place to be, but it also means that you as a team suddenly become way more effective and way more productive and way more doing things you never would have expected you'd be able to do. And that was great, and I hope people in sort of the RSC community are now being able to find those communities and set into them. And it's the thing I'm most actually looking forward to in the new position, where it's just this larger team, and suddenly I'm moving from being someone who's leading it to being part of this big thing. And it's just, as you were saying, it's kind of, I don't know this bit, but because we all trust each other, we all fill the gaps together, and it's a really nice, it makes working fun, I think.
I think one of the key things is supporting the research, isn't it? And because that's what we're here for. And if someone has an idea, then you try and help them see how that can fit best with what you've got. Or if someone has some funding, again, it's looking at seeing how you can take that funding and build bolt on, or integrate is probably a better word, with your system what they've got. whether it's an additional compute partition or whether it's additional storage, how that can integrate with the whole system so that the sum of the parts is greater than the individual bits, whereas if they had it in their own lab or whatever, it's sitting there, it's underused. If you put it in your big thing, you can share the use out and lots of people can use it.
Maybe just one thing from the library perspective, but I think it returns to what you were saying just then about kind of working with the researchers. That so the journey towards open research is obviously ongoing and changes all the time. But again, to return to the last 10 years, 15 years, there have been, there's been a lot done in that space, and we're seeing far more open research taking place and far more sharing of outputs. And particularly, I think what we're moving towards now is to sharing these outputs and resources across the life cycle, so not just at the end of a project, but actually thinking about the kind of the holistic approach to it. And one of the things that I think our team in the library has gone from being, it was very much, we were research services, which speaks something, but then the Office for Open Research is a much more, I think, it tells the world a bit more about what we want to do. And as part of that, we're able to engage much more effectively with colleagues in areas like humanities, which I think traditionally lots of humanities researchers don't really, it's not that they don't understand data, but they certainly don't think they work with data in the way that a colleague in atmospheric sciences would or in engineering. So I think this part of the journey and helping those researchers and colleagues to get on board with the benefits for open science and research for them, that's something that we really enjoy doing, and that's a big area for growth for us too.
Yeah, I think that's really, I like the way the conversation's moved on here. We're kind of off topic, but I think it's worth talking a little bit about it. It's about the working environment, how it affects your career, how it affects the quality of life. You spend, a third of your life at work. It's a lot of time, and if you're in a good environment where you've got people that support you, but you support as well, and you have a collaborative team spirit, that can make it so much more pleasant and so much more rewarding. And I think, just to raise some political topics, there are situations where we have people with lots of short-term contracts or only contracts at certain times of year, which makes it very difficult for those people. So whatever we can do as a community with our colleagues to ameliorate that or to make change, I think is something that we would be well worth doing. Certainly I found I've worked in various different places, and certainly the academic environment has a lot going for it in terms of that collaboration and cooperation. So yeah, thank you for steering in that direction. I'm just going to flip it now because we've got like 10 minutes left. So my question to each of the panel members is, have you got a little bit of novel technology that's your favourite, or you think is going to be the next big thing, like DVDs or tape or what's that thing? Oh, AI, yeah, that. And would you like to give a little talk about it and maybe sell it to the audience as so some ideas, some seeds of interest?
I think my favourite novel technology, it's been novel for a while. It's called the bicycle. It's very good for, it's very high utility. It's also great for net zero. But from a compute perspective, I think the thing that as I would quite like to get my, it sounds a bit boring, a bit stupid, but like to get my hands on is 96 gig DIMMs. Which, why is that novel? Well, I don't know. They're kind of priced on par with the 64 gig DIMMs, but just allows you to expand when you've got a memory intensive service. It's very important. It allows you to get more memory in there. Whereas if you scale exponentially if you go up to 128 gig DIMMs. So it sounds a bit stupid, but it's these sorts of things that we think about when designing these systems and trying to get the best price performance and that sort of thing.
What about bandwidth?
It's the same. Yeah.
Oh, it's the same. We need more.
It's just a DIMM. It sits in a slot.
Well, the bandwidth of the parcel it arrives in is 50% higher. So there's always that.
Amazon memory. Okay, I'll just patent that quickly while you carry on talking.
I mean, there's lots of interesting stuff that there's never time to explore that I would love to. Things around unconventional compute. There are people doing really interesting things, just getting random bundles of wires. I don't know if you've seen this stuff. You randomly put wires in, and with like just put them down, let them make random connections with each other, hook in inputs and outputs, and you can train it like it was a kind of a neural net and things. And there's analog computing where you have kind of just fluids and reactions and things going. There's all sorts of weird stuff that's great. Does it have an immediate application? Not that I'm aware of, but it's fun. I have a friend who does ant-based optimization, by which I mean she has ants, and it's not a personal problem. This is a research lab. But she puts food out for them and watches how they solve the optimization, how they find the food, and then how they do it. And that is in the York Centre for Complex Systems Analysis. And the point of that is to look at how these sort of real creatures solve real problems and see whether any of the problems we're facing in research might look a bit like that, and whether we could do that kind of thing. How practical is it? Well, there are some practical applications. Not every application can be solved by a lot of ants, but maybe there are some.
So do you have an annex of the Unseen University in York?
Could I maybe big up colleagues at the John Rylands Institute in Manchester, so just down the road on Deansgate, the beautiful John Rylands Library. But our imaging team there, this is maybe a novel technology that I certainly, when I saw it, was kind of amazed. So one of the things that they do lots of now, and this was a collaborative project with colleagues from Cambridge and others, is around multispectral imaging. So they have amazing kind of camera gear and imaging gear, and an application for that in the library's special collections is there's, and I'm not a special collections person, so I'll probably get this wrong, so apologies to colleagues who hear this afterwards, but a palimpsest, which is in the medieval era when they were doing writing and so on, they would, if it wasn't going to be a book, then they would have a piece of vellum or something similar, because it was very difficult to make paper, and they would write on this, and then when they finished that particular purpose, they would scrub it out and rotate it, and write again and do this again. And one of the things that the imaging team at Rylands can do with this, thanks to the multispectral imaging technology, is actually look deep into the makeup of the vellum and of the palimpsests and retrieve the information that was there previously, so they can see the writing that was there from hundreds of years ago that has been removed. And that to me is a really interesting way to use technology to kind of bring something back that, again, this is not the DVDs and CDs, but it's kind of, it was a storage medium of its time that is now being kind of rediscovered.
A multi-layered storage.
Yes.
Yeah. And how many shopping lists underneath?
Mead.
Chris, you got any thoughts?
I'm surrounded by new technology. I'm like a kid in a candy shop at the moment. But for me, the one which is, I think, most interesting is what's happening with basically federation and network. So it will be invisible to everyone. No one will notice it when it's running. But it's that ability if you just basically go onto a web page and then you click login, and then it just takes you to your university login, and then you log in with your university login, and then you have a link which has your Jupyter Notebook, and you click on it, and it starts the Jupyter Notebook, and then you run a job, and it just magically works. That's the thing that's really exciting me at the moment, which is a bit sad that network federation technology excite me, but they excite me because they're so underneath and hidden, and the fact that we have these kind of opportunities to really change the paradigm of how people access and use this stuff. And I really like there are so many technologies that come along that just suddenly change the way we work in the world, but you don't actually notice them, they kind of hide. And the Federation Technologies, Duke Access Management Federation, what's going on in terms of research and scholarship, and big meetings about how we get universities to release attributes from their identity provider so that you can have all of this work. That's the thing that's currently getting me going at the moment, which is rather sad, but it will be so impactful to everyone when it works. And if you don't know what I'm talking about, you will soon know about it, because we will be getting people to persuade their universities to release their research and scholarship IDP attributes. And there'll be a hit list of universities that don't do it and that we're going to try and persuade them to do. But it will mean then you finally don't have to remember 1 million passwords. You just log on to an infrastructure and SSH in using your normal university account, which is just going to be amazing.
I like that has your target is a valuable output in every sense to everybody, and not just a paper or some money. Well, my favourite, as you might have guessed from having built my own computer, is the variety of processors that we've got now, and the increasing diversity and range in the types of technology from the CPUs. ARM processors are really interesting, and I really hope that they get more coverage in the HPC arena to give Intel and AMD some competition, but also the processors inside GPUs and the merging of those onto one die and becoming actually self-hosted, so a system in their own right, so that we'll have a variety of different architectures to run our code on. And the software technology to generate the code underneath that. So I think it's time for the resurrection of compiler writers and people who write code generators. That's a really exciting field in my little world. So, audience, we need some more steps for the people who have got the microphones.
So I'm wondering if we've heard a lot of hardware technology, so I'm wondering if the panel had any thoughts on novelties in like the development side, so like programming language features, and like technologies that help us develop code in more interesting, faster, robust, etc., etc.
So I'm going to be really controversial, but I love GitHub Copilot. So GitHub Copilot in VS Code, and VS Code again revolutionized the way I programmed. I like the little samurai sword that starts with VI, and as the sword comes out, it's this Visual Studio Code. So GitHub Copilot basically learned my programming style as I'm programming, and it took away all of the boilerplate. And so it's almost like having a developer sat next to me who's kind of like filling everything in as I'm live going through. And it's just made writing code so pleasant and lovely because suddenly all the boilerplate's gone. It's like I hit tab a few times to accept things. I'm kind of crafting things. And I got rid of RSI because I don't need to type as much. It's really, really amazing and powerful. I encourage people to use it if you've not used it. The other thing that's really impactful at the moment is Rust. And I know everything is being rewritten in Rust. But the concepts of Rust are permeating into lots of languages. So if you look at the C++ profiles, which are C++ 23 or 24, something like 27 now, I don't know. C++ profiles are how you begin to then carve down the C++ language to say, actually, we want to not just work with pointers and be able to actually use all the memory safety guarantees and things like that. And this movement to a world where you're actually having, one, I love C++, but able to create new paradigms of programming, which Rust has kind of introduced. That's, again, really interesting, and I think it will help researchers be really productive in the same way that Python basically let researchers be super productive in 10, 15 lines. You're going to see similar levels of secure programming and similar levels of like, there.
Well, I mean, there's a lot in software. We haven't talked so much about GPU programming directly. We've talked about some of the advances in the hardware. I mean, one thing that I really would like there to be an advance in is programming GPUs, so that we have to care a lot less about them from a software perspective. And in particular, ways that we can write for GPUs that will also work efficiently on CPUs, so that we don't have to somehow double development teams just to handle all of these. So although I said in the previous panel about ARM and we've talked about ARM as the ecosystem, ARM is lovely. ARM you care about from the detailed performance, but actually mostly you just compile and it mostly just runs. Right? It's great. You might care, like I say, to get all the performance out, you might need to care a little bit more. GPUs aren't there yet, and I think that's an advance waiting to happen. But there are a lot of vested interests, and it's not obvious where we're going in the short term. So that's a challenge more than an opportunity. That's what I would like to see on the software side.
So I would counter with that's one of the real why we went down Grace Hopper, because you can do C++ numero programming, and you can do lots of interesting things, and that's the general direction it's going into. Is basically treating the CPU and the GPU as almost the same unit that you'll be able to begin programming and moving away from a world of CUDA into that world. I mean, we're not quite there yet. I'm not going to pretend we are, but that's the direction. And the fact you're having now NUMA baked into the language and really beginning to it's not just new and delete, but thinking about where you're placing memory at that level makes things easier to begin doing this programming both at the same time.
I mean, I agree that that's making it easier, but it's still not easy to move from NVIDIA to AMD, and the code that you develop for either platform runs like dog on the CPU. So if you don't have a GPU, it's quite bad.
Yeah.
I mean, one day this has to change, but
There will never be a time where your code on a GPU will run at the same speed on a CPU, because the GPU is just way more capable. And I think this is kind of the future. I mean, people are calling it AI PCs, but the future is essentially not a single homogeneous processor. It is that kind of mixed thing, and you begin targeting different bits of the processor with different codes.
I think one of the things that's shown potential to have potential for a long time, for 20 years or more, is FPGAs, and they're not here yet. They're probably still 10 years away. Maybe like fusion, they'll never come. Well, they will come eventually, I guess, but quantum, whatever. But you know, I would like to see something, you know, take shape there, because they have so much potential in terms of the compute power they can provide, particularly in terms of data flow through them. And it potentially is somewhere where AI could help with the programming models there. I suppose there's a lot to get right, but you know, that would be an interesting thing to see.
I mean, actually, on that, there's one of the things that the LHC community do is they actually use AI models to train a model for detection for the trigger, and then the inference is on FPGA for power. And I think that there's a real market actually in terms
right,
of
that sort
doing
of stuff.
inference on an FPGA.
Yeah, that's right, that sort of stuff, because they are very well suited for some workloads if you think slightly outside the box. But to get the maximum efficiency out of an FPGA, you know, it's a lot hard. You can't go and program in C, C++ and let some compiler convert it for you. You have to think a completely different paradigm. So.
I think we had another question. Matt, was that you?
Thanks for being asked the question.
Fantastic. Any questions online? Have they all? They've all gone to lunch already.
we all burned them out in the previous panel.
Given that security is possibly the most important thing in computing these days, what about security technologies, particularly ones that are 40 years old? I mean, I'm thinking of things, well, particularly capability security, object capability security, which seems to be very much something we need, and possibly also formal methods, whether they're explicit, proving that your MPI doesn't deadlock or whatever, or implicit in powerful type systems.
So I think a lot of the formal methods basically are things that went into Rust and then kind of coming into the C++ in terms of...
Actually, most of that, the non-problematic bits came from Haskell, as I understand it. It's the troublesome borrow checker thing that's new.
Yeah, so I'm not saying it came, what I'm saying is the community is embracing it through Rust. So you're kind of seeing this kind of, on the link step, having that formal verification of the program, at least in terms of the memory safety. I mean, not in terms of the logic underlying it. And it's one of the challenges, I think, with Rust, there are no shared libraries because you have to compile the entire application so that you can do that formal check at the static link time. And so there isn't yet a concept of an ABI that enables that contract to cross the ABI boundary. I think the interesting thing in the software development community, or the compiler developer community, will be how they begin to build ABIs, which are application binary interfaces, which enable you to do that verification checking across the shared library boundary. So I think those tools, I think, beginning to come in and beginning to be seen rather than just be academic.
Any other comments? Because it looks like it's lunchtime to me. Okay, thank you very much. Can we thank the panel, please?